Now come to the next instrument, that is called ammeter. So what is the purpose of this instrument? So ammeter is a device which measure current, but the previous device also was the device which measure the current, but the difference is that the ammeter measure higher current, but in the galvanometer we were able to calculate only the current in the range of milliampere as well as in the range of microampere. But the ammeter is device which can measure high current. So we can write it is a device which measure large current in the circuit, large current in the circuit. It is always connected in series with the branch. It is always connected in series with the branch across which current has to measure. Current has to measure. So first of all, just like in galvanometer, it is also connected in series with the branch in which current has to measure. But how we are connecting? As we said or we discussed in the previous section, the galvanometer is a fundamental device. Similarly, ammeter can be made with the help of that fundamental device. So we can write a galvanometer can be converted into an ammeter by connecting a suitable small resistance in parallel with the galvanometer. That resistance is called shunt resistance. That resistance is called shunt resistance. That resistance is known as shunt resistance. See, just like this is your galvanometer, and these are the terminal of a galvanometer, that A and B. As we know, galvanometer has certain limitation. It can take only current in the range of milliampere or microampere. So current a galvanometer can have, that can be said as your IF. IF is called as a full scale maximum current. IF is the full scale deflection current. Full scale deflection current. Meaning is that this is the maximum current a galvanometer can have, or it is the maximum current a galvanometer can have. A galvanometer can have. Now, and G is the galvanometer resistance. So since galvanometer can have maximum current IF, but if my current or current which we want to measure, which is large enough as compared to IF, so if direct current goes to the our direct current passes through the galvanometer. Because of very high resistance, galvanometer, inside a galvanometer a huge amount of heat develop and it can burn. So what we will do, we will make here bypass, or we can connect a resistance parallel to galvanometer. This is called shunt resistance and we are representing this with S. It is called your shunt resistance. Then what will happen, when I current is enter through the instrument, only IF, we should adjust the value of S like that, only IF should go through the galvanometer, remaining current should pass through the shunt. Through shunt current will be your I minus IF. So finally this is our instrument which is ready. So now this device can be said as a ammeter. So we can make this with another diagram, and let this is called your terminal A and B, and now here ammeter, so this is your RA. RA can be said as a resistance of ammeter. So RA is the resistance of ammeter. Now it can have current your I. So RA is the resistance of ammeter. RA is the resistance of ammeter, and this is nothing. These two are in parallel. G and S are in the parallel. So value of RA is G into S by G plus S. This is the value of resistance RA. So now how to calculate the required shunt value? See, now we can use here these two resistance. These two are in parallel to each other. So potential difference between A and B should be same. Either we are going from this path or we are going through this. So we can write here I minus IF into shunt value, which is equal to your IF into G. So shunt resistance can be written as IF by I minus IF into G. So this is the desired value of shunt depending on the current or the range of current which we want. As I may be in the range of ampere, maybe it is 10 ampere, maybe it is your 100 ampere, but IF is in the range of milliampere or maybe in microampere. So as I is very very large as compared to IF, so we can have S is approximately your IF by I into G. So shunt resistance can be given by this expression also. So this is the basic construction of a or conversion of a galvanometer into ammeter, but there are certain problems here also. So we can have, see, this device is also connected in series as it is given. It is also connected in series with the branch across which current has to measure. So when we are connecting any device in series, so since it has some resistance RA, so when we are connecting an ammeter with the series, so that increases the resistance of that circuit. So as the resistance of the circuit increases, so current in the circuit slightly or decreases. So what can be said? So when we are connecting a ammeter to the circuit, ammeter actually measure little bit less current whatever the our desired value. So there is always certain error in the ammeter reading. So now we would like to calculate how much is the error in the ammeter reading, and either that error can be nullified or that can be removed or not. To see.